Cool. So what are some of the Hive challenges that we've seen? And this is not an exhaustive list. I'll say that Hive is a great technology, great platform, and we learned a lot from it over the last 13 plus years. But it's getting old. It's getting a bit outdated. There's not as much development around it or innovation around it. It's not as fast or efficient anymore. We've seen Spark and Flink and some of these other engines really taking advantage of some new technologies and new ways of handling data that's more efficient than Hive. So Hive as a compute service is starting to kind of die out. However, there's lots of it, right? There's lots and lots of companies who still use it fairly heavily. And that's a different type of migration of migrating those workloads to Spark, for example. Hive Metastore is the other component of the Hive ecosystem. That's the piece that catalogs your tables, records the schema, records the partition information, and is used by query engines to find the data and find how to access that data. Now, it is reaching its limits. In particular, there's concerns or issues with the data model of the Hive Metastore. It's limiting because it's not as robust. It never expected to have thousands of columns that we see today in very wide tables. The data types fairly static. We want to be able to move to different types of types like variants and things that are more applicable to embeddings and things like that we do in ML. Performance is not so great, right? It's becoming harder and harder to scan or to process very large tables. I know for my day at AWS, we always had lots of challenges with customers who had very, very large tables, millions of partitions. Now, when you go to run a query, that query planning period where you ask the catalog to say, give me all the partitions, they need to figure out which partition you want. That process started to take a long time and almost counted for more than half of the total execution time of a query. So we're seeing that more and more as these data lakes get bigger. Also, when you look at the kind of like the data side, right, there's lack of mutability. So if you are using Hive, even if you're using Spark without this type of table format, like you can't safely update or delete rows without having to delete the entire file and upload a new file. There's no built-in compaction or cleanup functions. This comes up often with companies who are building on top of Hive-based data lakes and saying, like, how do I compact a bunch of small files into bigger files that are more efficient for queries? Well, in the Hive world, you got to write your own code. In Iceberg, there's already a default standard implementation of how to do this, that you simply make a function call and it just does it for you. Now, it's something Absolver automates and makes it easy for you as well if you are not using Spark, but that functionality is defined and easy to use. Lots of other things. I do want to make it clear that Iceberg does work with Hive. So if you are using Hive Metastore, you're not ready to move away from those, but you do want to use Iceberg as your table format, you can do that, right? It's well supported in the library and you can use it.